Welcome to Chapter 8, where it's all about right triangles and trigonometry. Today we're going to talk about the Pythagorean theorem. Hey, I think I remember what that is. Oh, yeah, you do. For every right triangle, we have the Pythagorean theorem. So if it's a right triangle, then we have that a squared plus b squared equals c squared. The key part is what c is. C is always going to be the hypotenuse, and you should be able to label the hypotenuse that's straight across from your 90-degree angle. It does not matter where you have A and B necessarily, as long as your hypotenuse is always straight across from your 90-degree angle, and that's always what the other two lengths is equal to. So what's the hypotenuse? So if I put C here, and it doesn't matter where you label A and B. So I'm going to say this is A, this is B. So if I'm going to have the equation a squared plus b squared equals c squared, then I'm going to have 21 squared plus 20 squared is equal to c squared, because I don't know what c is. 21 squared is 441, and 20 squared is 400. So I'm going to add those together, and I get 841 is equal to c squared. Now, in order to get c by itself, I have to get rid of this square right here. I have to take the square root, because that's the opposite of squaring something. Remember, whatever you do to one side, you have to do to the other. So if I take the square root of that, that's going to be 29. Typically, when you take the square root, you should have a positive and negative. But when I'm talking about length here, this is the length of AB, then it's always going to be a positive number. Length should always be positive. So that would be my final answer. I want you to pause the video to see if you can get the correct answer for Ln. You should have gotten that C is equal to 17. The process is still the same, and remember, it's always going to be a positive because I'm talking about length. This problem is going to be a little bit different because I'm looking for x, but in simplest radical form. So first thing I do is always label my C. My C is always across from my 90 degrees, and it doesn't matter where I put my A and B. So I'm going to replace A with x squared plus B is 8 squared is equal to C, which is 20 squared. So I have x squared plus 64 is equal to 400. I have to get the x squared by itself, so I have to subtract 64, so that's going to be 336. Now I have to take the square root on both sides of the equation. There's two ways to do the simplest radical form. You can look at 336 and see if it's divisible by any perfect squares. I'm going to show you two ways to do this. So x is either going to be equal to, I could split this up so it's the square root of 16 times the square root of 21. And since 16 is a perfect square, because how did I get 16 and 21? Because 16 times 21 is equal to 336. Then I know that x is going to be equal to 4 square root of 21. Because there's no other perfect squares in 21, meaning 4 or 9 or 25, knowing your perfect squares. If you don't know your perfect squares as well, then you should be doing a factor tree. So if I have 336, I want to figure out what the multiples of 336 are. So I could do 16 and 21, and I could do 4 and 4, 3 and 7, 2 and 2, 2 and 2. Now, when I'm taking the square root of a number, that's like there's a 2 here. That's an index of 2. So I'm looking for pairs. So here's a pair, and here's a pair. Anything that's circled comes out. So I would have 2 times 2, because those are both circled. And anything that's left over, like the 3 and the 7, stays within the root. So 3 times 7. And then you should simplify always. So my answer would still be 4 square root of 21. Either way, you're going to get this right answer if you do it correctly. Word problem. I know I'm going to draw a picture right away. For every word problem, you should draw a picture. So right away, I'm just going to draw a right triangle, because that's what I'm dealing with. Jamal leans a 12-foot long ladder. So if this is my ladder, because it's leaning against my building, this would be 12 feet. The base of the ladder is 4 feet from the house. So if this is my house, then it would be 4 feet from my house. To the nearest tenth, how high does the ladder reach? So if I set up my equation, C is always straight across from my 90 degrees. So x squared plus 4 squared is equal to 12 squared. So x squared plus 16 is equal to 144. X squared is equal to 128, and then I take the square root of that. Because I'm rounding to the nearest tenth, I would put this directly into my calculator. And to the nearest tenth, that would be 11.3. And my units here would be feet. Whenever you have a word problem, you should always make sure to look at what are my units. So the converse to the Pythagorean theorem is saying, if I know I have a triangle and a squared plus b squared equals c squared, no matter what, that will be a right triangle. So this is just saying, if I know this, then it will be a right triangle. So be able to classify triangles. When we have a squared plus b squared equals c squared, and they're all perfect numbers, that's called a Pythagorean triple. The best Pythagorean triple would be 3, 4, and 5, meaning 3 squared plus 4 squared is equal to 5 squared, because 9 plus 16 is equal to 25. So this is the best, most well-known Pythagorean triple. So I'm giving you the side lengths, and you have to decide, is this a right triangle? So I have to see, does a squared plus b squared equal c squared? Well, whenever you give the 3 side lengths, again, it doesn't matter about a and b. C is the one that matters the most. So I look at these side lengths, and c would be 85. Why? Because the longest length is always going to be 80, or going to be c. Longest length is always c. First thing you do is set up a squared plus b squared equals c squared, and then you actually square the numbers. So now I'm going to have to combine 7,056 with 160. And I get 7,225, which was what 85 squared is. So this is a Pythagorean triple, so yes, this is going to be a right triangle because a squared plus b squared equals c squared. Now what if I have a triangle and it does not equal? Well, that means that triangle is either going to be obtuse or acute. So if I were to test my numbers like this, and c is larger, if c is larger, that means it's always going to be an obtuse triangle. So let's say if c is smaller, then it's always going to be an acute triangle. So you can always use a squared, b squared, and c squared to be able to classify triangles. Either it's going to be right, obtuse, or acute. It all depends on what your c is compared to a and b. So let's test it out. So when I first look at this, I'm going to have a is going to be equal to 6, b is equal to 11, c is equal to 14. Again, it doesn't matter a and b as long as 14, your longest side, is c. So I'm going to test a squared plus b squared, and I'm going to see what that is. And then I'm going to test c squared, because I don't know if they're going to be the exact same. So my a squared plus b squared is 157, and my c squared is 196. So right now, my c squared is larger than a squared plus b squared. That means this triangle is going to be obtuse, because the c is larger. Right now, I want you to try this one all by yourself to see if it's acute, obtuse, or right. You should have gotten that this is a acute triangle because my a squared plus b squared is larger than my c squared. So since these two lengths together are larger, then it's going to be acute. Make sure you took good notes and have a great, grand, wonderful day.